This is George Sicalius, and this is Sprint 4. Okay. So I have my player group over here. I have my enemy group over here. My enemies are set to collide on self. That's why their B-spheres are currently visible. So if the two groups intersect, it'll then start doing B-sphere testing between the two groups. And then if so now it's doing B-sphere testing. If it passes B-sphere testing, it'll go into testing the actual volumes on the objects. Okay. So all collidables now have a B-sphere along with their actual collision volume. I'm computing the B-sphere inside of update collision data. After I update the data for the B-sphere, I then send that to the collidable manager using a command. So this passes the data for the B-sphere to the collidable group. That will then use that data to compute the min and the max for that for the ABB for the collidable group. So yeah, I'm storing a collision volume inside of the collidable group, and then I also created a command, which I give to the collision manager, which tells the given collidable groups to compute their AABBs. So that's what this is right here. Going into collision manager. Did I say collision manager? Yeah, the command goes to the collision manager. Just making that clear. So prior to processing all of the pairs, it calls compute group boxes, which executes the given commands and actually computes the ABBs on the collidable group. So yeah, that's what's happening right there. So then it does that, it then processes the pairs, and then it resets the min and the max for each of the groups. Inside of collision test pairs, I now have a tiered collision. So first it'll test ABB collisions if ABB pass. Then it'll test B-sphere collisions on each of the collidable objects inside the collidable group. And if the B-sphere test passes, then it tests the actual volumes. Test self. Since all the objects already belong to the same ABB, I can't really test that, so I just go straight into testing their B-spheres. If their B-spheres test passes, then it tests the actual collision volumes. So that's it for updated collision system. Just small aside, so I went through my game design doc. I added a bit more stuff to my schedule, try to reorganize it a little nicer. I also added a couple of features that I'm planning on adding, also including methods for how I'm planning on implementing that. And yeah, I'm gonna include a copy of this in my next sprint, in this sprint. So I'll talk more about this more in specific. This is my game engine using DX. So I imported the collision system. I'll have to go over how I'm computing the center and the min and the maxes and all that stuff for the actual models, because as you can see, it's a bit off. But yeah. And I also whatchamacallit, implemented all of the rest of the shaders into the my current engine. Um, so this week I moved all of the window initialization and DX initialization stuff inside of Run. So this is the main now. Run also has the main game loop right here. So yeah, and also now my game engine actually derives from my DX app, which is now called Engine. Um, so yeah. So in resource loader. So yeah, I think I showed you this a couple weeks ago. So the user can now load in resources. The naming conventions is gonna have to change later down the line, especially for textures. Um, as I said, I added in the other shaders. Um, and the user can now set the background color as well as the window dimensions. Um, so going back into Run Engine. So yeah, inside of Run, it calls initialize, which grabs the window width and height and color, stores that away, and then uses those values to create the actual window. Next week, I'm planning on implementing and wrapping the key tests. So like the stuff for inputables. I'm also planning on including the stuff to get the alarmable system working. So that's just, I'm pretty sure the engine already does it somewhere. Just keep track of the system time and make that retrievable. So yeah, that's all I have this week.